Hello, welcome to Math-073. My name is Rob Reynolds, and today we're in Chapter 6, Section 3, and we're going to continue our discussion on radicals. We're looking at today multiplying and dividing radical expressions. So the first thing you need to know is the rule, the square root of AB is the square root of A times the square root of B. And so I'm going to keep saying, if it's together, we're going to pull it apart. If it's apart, we're going to put it back together. And this demonstrates, if it's apart, we can simplify. The square root of 4 is 2, the square root of 9 is 3, and you could also multiply 4 times 9 and get 36, and the square root of 36 is also. So again, if it's apart, we're going to put it together, and if it's together, we can pull it back apart. And you can remember that if you have the square root of 3, you can write that as 3 to the 1/2, because you have a little, nobody ever writes this 2, but that's what the square root is, and nobody ever writes this 1, but that is 3 to the 1st, and that's this definition here. But again, if it's apart, we can put that back together. So let's look at this. This is apart, so we're going to put it together. 5 times 6 is 30. And then let's try to, if it's together, let's pull it back apart and see if we can simplify this. Well, there is no perfect square that goes into 30. I'm looking for numbers like 4, 9, 25, 16, and so I can't pull it back apart. But I would look for it and see if I could. Let's try this next one. The cube root of 63. Well, perfect cubes, 2 cubed is 8, and 3 cubed is 27. 4 cubed is 64, and none of those numbers go into 63, so I think I'm done again. So let's put this back together, because it's apart, so it's the 4th root of 5x over 3z, and there's nothing I could do with that. So again, final answers. I'm always looking to see if I could simplify some more. So again, if it's together, we can pull it apart. We could also distribute these, so I would say if this is together, we can pull that apart. You can pause the video and read how the author explains. So here we go. This is together. I'm going to try to pull this apart by finding perfect squares, and I know 100 is a perfect square. So I'll write this as the square root of 100 times the square root of 3, which is 10 squared, it's a 3. For this one, I'm going to try to pull this apart. This is the square root of 8, which, by the way, could be written as the square root of 4 times the square root of 2. The square root of m to the 4th, which is really m to the 4/2, and then the square root of n. So what's going to happen here is I can't do anything with these two terms, so I'll just rewrite those two terms, and I'll put those back together. And I'll bring these two terms out front. So I have a 2, because the square root of 4. M squared, I can't do anything with that. And then these two things are underneath the radical, and I'll just, again. So here's pulling apart, and then here I'm putting back together. So first you pull, if it's together, you pull it apart, which is I did here in this line, and then these two lines I'm simplifying and putting back together. So let's do it again. If this is together, I'm going to pull this apart first. The cube root of s to the 4th. Then I'm going to try to find a perfect cube. And remember, on the other slide, I found perfect cubes. It's 2 cubed is 8. And so I want to check to see if 54 divides by 8, which it does not. So I'll go to the next one. 3 cubed is 27. So I think 27 does go into 54. So I'm going to write this as the cube root of 27 times the cube root of 2, because 2 times 27 is the 54. And I'm going to do the same thing with this s, which kind of looks like a 5. I'm going to break this up to be the cube root of s cubed times the cube root of s. So I've got a couple things going on here. The 54 broke up to 27 times 2, but the s broke up to s cubed times s. Because you rewrite the base and add the exponents. The reason that I'm doing that is because I know the cube root of 27, and I know the cube root of s cubed. The cube root of 27 is 3. The cube root of s cubed is s. And then what's left is these two terms, which I'm going to throw back together as the cube root of 2s. So again, if it's together, I pulled it apart, and then once it's apart, I put it back together. Let's see, 2m squared. I have the cube root. Oh, there it is. 2m squared. So we want to make sure that we're not writing this one as 2m square roots of 2n. So make sure that 2 is clearly on the m and not part of the square root sign. But it was this third answer. There it is. There's the one I was looking for. 3s. And again, this needs to be clear. This is not the same thing as 3s cubed square roots of 2s. You need to make sure that 3 is part of the cube root. So 3s, that works. All right, so let's do it again. Can't do anything with the square root of 7, but x to the 5th can be broken down to the highest exponent. So here's what I would think about. 5 does not divide by 2, but the highest exponent that does is 4. So I'm going to break that down to be x to the 4th times x. Because if you multiply this back together, x to the 4th times x, you'll get it x to the 5th. So this is really x to the 4 halves, which is really x squared. And these other remaining terms in blue, I can't do anything with. So I'll just write those underneath the radical as 7x. Problem B is 324. We'll try to break that up. 7 doesn't divide by the 2, but I'll go the highest that does, which is a 6. And 5 doesn't divide by 2, but I'll do the highest that does, which is a 4. So now I've got to come up with factors of 324. I'm going to try to pick the highest perfect square. And it looks like 4 goes in there 81 times, which is really nice because they're both perfect squares. So this just breaks down to 18. And x to the 6th is 6 divided by 2 is a 3. I'll bring out the y. 4 divided by 2 is 2. And then these two terms I can't do anything with, so I'll rewrite those as the square root of xy. Final answer. The last one, the cube root of 24, I'll try to break up to be the cube root of 8 times the cube root of 3. I'm going to break up that 8 doesn't divide by 3. I can't go to 9 because that's too high, so the highest that does divide by 3 is a 6. And that will leave me 2 a terms. And then that 9 does divide. So this is a to the 9/3. And that does divide, and we'll simplify that in a moment. So the things that we can simplify are this term, and this term. So I'll bring all of those out and make it the cube root of 8 is 2. 6 divided by 3 is 2. And you know, it probably would have been smart to put this together first and rewritten this as 24. I didn't even notice this. Bases, oh, that's a b. No, bases are not alike. Oh, I miswrote here. So this is a b term. If those were both a's, then I would have done bases alike and added and gotten to the 17, but so this should be a b term as well. Sorry about that. So this is b to the 3rd, and then what's remaining is the cube root of 3, and no, that's an a term. Shoot. This wasn't a, because all of this was a to the 8th. So what I should have left are the two pink terms, which I'll put back together, the cube root of 3a squared. Well, let's see if the author agrees with this. So this one was okay. 18x cubed. Yep, that's okay. And this last one, which I bouched, I think I finally got it right. Yep, the cube root of, yep, I think that's okay. All right, apologize for that. Let's do this again. If it's apart, I'm going to put it together. This is the square root of 60, and if it's together, I'm going to try to pull it apart. So the square root of 60 can be written 4 times 15. Again, I just try in perfect squares, and 4 was the first one that worked. And 2 square roots of 15 looks like it's going to be simplified. This one's apart, so I'm going to put it together. The cube root of 9 times 9 is 81. Let's put these together. Rewrite the base and add the exponents. And putting the y's together, rewrite the base and adding those. And then I'm going to say, well, this is the cube root of 81. Again, it's together, so I'm going to pull it apart. The cube root of, instead of writing x to the 7th, let's break this down to be 6 and 1. And then y to the 9/3 actually divides quite nicely. 81 is not a perfect cube, but I know that 3 cubed is 27, and I think 27 goes into 81 3 times. This is x to the 6/3, and we'll make this y to the 3rd. So I'm going to pull out all of these yellow terms and write them here, because I can simplify the cube root of 27 to be 3, x squared y cubed, and then all of my remaining terms in pink, oops, that would be here, are going to be put back together, the cube root of 3x. And I think that would be final solution. Cube root of 3x. Yep, that's what we had. All right, so one last rule. If you have a quotient, the square root of a divided by b, if it's together, you can pull that apart. And by the way, if it's apart, we can put it back together. So for this one, I would try to simplify, and fortunately for us, 48 divides nicely by 3. That's the square root of 16, and the square root of 16 is 4. Let's do the same thing. This 2 is just going to kind of hang out down there. Maybe you could write it as a 1/2, and then make this the cube root of 24x to the 4th, y to the 5th, divided by 3x. So now I think I can simplify 24 divided by 3 and x divided by 4, reducing this. So I still have that 1/2 kind of hanging out there. This is the cube root of 24 divided by 3 is 8, x to the 3rd, y to the 5th. Let's pull this apart. 1/2 hangs out there again. The cube root of 8, I think I know. This is x to the 3/3, which I can simplify to just x. And then the cube root of y to the 5th. 5 does not divide by 3, but 3 does. So I'll write this as the cube root of y cubed and y squared. Again, I'm breaking down this y to the 5th to be y cubed times y squared, and choosing the highest exponent. So let's see what we have left here. The cube root of 8 is 2, so half of 2, all of this just cancels to just 1. This is an x term I'll just bring down. This is a y term, which I can just bring down, and I'm left with the cube root of y squared, and that's final answer. xy cube roots of y squared. So we have 4 for answer A, In answer B, it looks like the author agrees with this. xy cube roots of y squared. Again, if it's together, pull it apart. If it's together like this, by the way, we can distribute to the numerator and denominator. So I would say if this is together, we can pull that apart. So let's pull this apart. The square root of 49 over the square root of x to the 4th is 7 over x squared. This, nothing reduces in here, which would be the first thing I would check. So if I can't reduce, then let's pull it apart. I could even write this as m cubed times m. And you'll see why I did that in just a moment. I can see that I'm going to try to simplify this. So the cube root of 54 can be written as the cube root of 27 times 2. This is m to the 3/3, and then the cube root of m. All divided by, can I just call that n, because the cube root of n cubed is n to the 1st. So simplifying this, the cube root of 27 is just 3. Oh, and I have an m. I should make that in yellow as well. So this is my yellow terms, and then my blue terms I can't do anything with, so I'll just write those as, I'll put those back together because those are apart. And again, the rule is if it's apart, we'll put it back together. All divided by n. So I'm pulling apart, putting back together. There was the first answer, nice, and then the second answer. Well, I guess here's where I'm supposed to do the work, but it looks like we have the same answer. I hope you found this video helpful. If you have any questions, feel free to email me. Good luck.